What is convolutional neural network? A convolutional neural network is a type of deep learning neural network architecture commonly used in computer vision. They are one of the most powerful and widely used tools in machine learning, particularly for image recognition and computer vision tasks. In the case of images, the network can first detect low-level features like edges or texture in the early layers, and then combines this into more complex features like shapes, objects, or faces in the deeper layers. This makes convolutional neural networks incredibly effective for tasks like object detection, face recognition, scene understanding, self-driving cars, and also medical image analysis. Imagine that you want to play tic-tac-toe game in your computer online. Computer needs to recognize handwritten numbers, and here CNNs make sense.
Now that we have discussed the general concept of convolutional neural networks, let's dive into the key building blocks that make up these powerful models, the layers. CNN are composed of several types of filters, each with a specific role in processing and learning from the input data, typically images. Convolutional layer. This layer is the first layer that is used to extract the various features from the input images. In this layer, the mathematical operation of convolution is performed between the input image and a filter of a particular size MXN. By sliding the filter over the input image, the dot product is taken between the filter and the parts of the input image with respect to the size of filter. The output is termed as the feature map, which gives us information about the image, such as the corners and edges. Later, this feature map is fed to other layers to learn several other features of the input image. Pooling layer. In most cases, a convolutional layer is followed by a pooling layer. The primary aim of this layer is to decrease the size of the convolved feature map to reduce the computational costs. This is performed by decreasing the connection between layers and independently operates on each feature map. Depending upon methods used, there are several types of pooling operations. It basically summarizes the features generated by a convolutional layer. In max pooling, the largest element is taken from feature map. Average pooling calculates the average of the elements in the predefined sized image section. The total sum of the elements in the predefined section is computed in sum pooling. The pooling layer usually serves as a bridge between convolutional layer and the fully connected layer. This CNN model generalizes the features extracted by a convolutional layer and helps the networks to recognize the features independently. With the help of this, the computations also reduced in a network. Fully connected layer. The fully connected layer consists of the weights and biases along with the neurons, and is used to connect the neurons between two different layers. These layers are typically placed before the output layer and form the last few layers of a CNN architecture. In this, the input image from the previous layers are flattened and fed to the fully connected layer. The flattened vector then undergoes few more fully connected layers, where the mathematical functions operations usually take place. In this stage, the classification process begins to take place. The reason two layers are connected is that two fully connected layers will perform better than a single connected layer. These layers in CNN reduce the human supervision.
Now, I'm going to talk about how does CNN work. Here you can see the handwritten number 9, and 9 should be recognized to computer. First step is creating filter or kernel for calculation. After that, we should multiply filter by 3 by 3 matrices of image. So we sum up them and write them corresponding places of table. This is called feature map. And the next step is the ReLU function. ReLU function is activation function which select max value between number and 0. This means that there is no negative. Processes, as we explained, are happened in convolutional layers. The next layer is pooling layer, which is used to reduce size of images and neurons. We take max number of 2 by 2 matrices of feature map. Then the last step is flattening layer. Here numbers are flattened to find output based on the calculations.
Convolutional neural networks have revolutionized many fields due to their ability to automatically learn complex features from raw data, particularly images. Let's take a look at how CNNs are being applied in real-world scenarios. Face detection. From unlocking smartphones to identifying people in security systems, CNNs are the core of modern face recognition technology. They can detect and identify faces even under varying lighting conditions, angles, and expressions. Computer vision. CNNs are widely used in image classification, object detection, and image segmentation. For example, CNNs are the backbone of systems used in autonomous vehicles for recognizing pedestrians, road signs, and obstacles. Natural language processing (NLP). Although CNNs are more commonly associated with images, they have also been successfully applied in NLP tasks like sentimental analysis and text classifications by recognizing patterns in the sequence of words. Medical imaging. In healthcare, CNNs help analyze medical images like X-rays, MRIs, and CT scans to detect conditions such as tumors, fractures, and other abnormalities. This can assist doctors in diagnosing and monitoring diseases more accurately.